guys, my name is Christine, and today we will talk about the electrical transmission through a synapse. So I will draw this is our synaptic cleft. So this is our synaptic cleft. And then also we have this is presynaptic cell. And this is our postsynaptic cell. Okay, so when we have the electrical current, the electric current, when it transfer and it go to the presynaptic cell, then it will open a gated channel, a voltage gated channel for calcium. And when the voltage gated channel for calcium is open, then we will have a rush of all the calcium into the cells, into the presynaptic cell. So when you have the rush of all the calcium into the presynaptic cells, then we will have all the vesicle here that carry the neurotransmitter. All of this vesicle, it will migrate into our synaptic cleft, and it will blend into our membrane right here, and it will diffuse, and then it will release all of our neuron transmitter right here. So we can see from here, it will release, and then we have all our neurotransmitter will now go into the synaptic cleft. And when all our neuron transmitter here go to the synaptic cleft, then it will diffuse as a chemical gradient onto our postsynaptic cell, and here it diffuse. And meanwhile, we will have on our postsynaptic cells, we will also have all the ligand gated channel. So this is our ligand gated channel. And here, remember that for our dendrites, which mean our postsynaptic cells, we do not have our voltage gated channel. We do not have voltage gated channel. So because of this, we only have ligand gated channel. This is our ligand gated channel. And so when we have all of our neurotransmitter come here and then it's bind to our ligand gated channel, then this ligand gated channel will now open, and then all the information can start going down this way to the dendrite. So there are three different types of information synapse that we can have. Three different types. We can have an excitatory synapse, but we also can have an inhibitory synapse, right? And also we have another one that is modified. It is monitored by G protein. So if in the excitatory synapse, this ligand gated voltage channel will be actually the ligand gated channel of sodium. So when sodium rushes into this, it will cause depolarization. And when it's called depolarization, we will have it excite and it transfer, it's cause action potential. And in the inhibitory synapse, we will actually have the chloride for ligand gated channel. And when we have the chloride ligand gated channel like this, the ligand will actually rush in here, and it will cause repolarization. And we want to recall that when we have depolarization, it means that when we make the voltage inside the cell become more positive. That's why when Na plus rush inside the cell, we have it bringing more of the blood charge into the cell and make it more positive. That's why we have depolarization. But in opposite, we have repolarization is when we have making the voltage of the inside of the cell become more negative. And more negative, in this case, if we have chloride bringing all the negative charge into the cell and make it more negative, that's why we have a repolarization. And when we have a repolarization, we will cause the inhibitory effect and will cause no action potential. Another synapse that we get monitored by G protein is that when we have G protein, it would generate the second messenger. It would generate the second messenger, and that's what causes all the cascade, and then we will have all the later information that would translate later. Okay, so that's the three type of synapse, and that's how synapse work. And also after we have all of this, the vesicle rush in here, bringing all of our neurotransmitter here, the transmitter bind into the ligand, open all the ligand gated channel, and transfer, make all their information keep going to another neuron. In order to for our synapse to keep working and to receive another stimulus, we need to clean up all of this. We need to clean up all of our neurotransmitters somehow for the information to regenerate. So in order to do that, we have three ways to clean up all of our neuron transmitter. The first one is that it can diffuse into the interstitial fluid. It can just diffuse by using chemical diffusion. The second way is that some of the neurotransmitter that is really close to our presynaptic cells that can get reabsorbed, get uptake in by using a transporter. A transporter will uptake all of our neurotransmitter, take it back into the presynaptic cells. And another way we have is that we have an enzyme here located on the postsynaptic cell that can convert all of our neurotransmitter, break it down to something else, right? Break it down to something else. And when it breaks it down to something else, then it can no longer bind to our ligand gated channel, and that will shut down the system. It will recollect and shut down. And so now our synapse can receive another stimulus.